Assalamualaikum warahmatullahi ta'ala wabarakatuh and good day to each and everyone. So this is Sir Hanif, your instructor in EE223. So the description of this subject is mathematics for electrical engineers. So specifically, um, we will be tackling about all methods and kinds of mathematical problem or approaches that can be used in dealing with the concept of electrical engineering. So um, I have not yet given you a orientation, no, in my subject here in EE223, but um, anyway, this is just specifically for electrical engineering. So and I know that um, we have not yet um, reaches our we have not yet reaches our very tough number of students. So I'm so I'm assuming that all of us uh, all of us knows how to be a student, no? Yeah, with in regards to dealing with your instructor and the subject that you are having. Okay, and of course I'm assuming that you have already have your um, orientation with your other subject. So I think that is the same with my own, no, in regards to the laws. I mean rules and regulation in taking all the subject that you have. But what I'm uh, pointing out here is the grading system. Although I have not included it here, so I will be pointing out here that our grading system is same as your instructor have other instructor have, no? So I have a prelim, which is 20%, then midterm, which is 20%, and final, which is 30%. And other the other 30% is due to the quizzes, not 20% for the quizzes, and the exams, I mean the attendance is 10%. Okay, so the usual one actually. So and for the other rules and regulation, as I have said, um, same pa rin yun siya sa other instructors, no? For the online classes, no? So you may just have to refer on it. Okay, so now this would be the first topic that we have, and in this week one, which is the linear algebra, vectors, determinants, and linear. Okay, so basically we will just use these mathematical tools here, the vectors, determinants, and the linear to further understand the different applications of mathematical here in this subject. So once again, I'm your instructor, Engineer Hanif M. Makainig, um, or you can just call me as Hanif, Sir Hanif. Okay, so this is EE223. Okay, the mathematics for electrical engineering. Okay, so now let's begin. So we have here the matrices, vectors addition, and scalar multiplication. So we have here a matrix is a rectangular array of numbers, functions which we will enclose in brackets. For example, this one, no? This is a matrix. Okay, so matrix has a enclosure which called as a bracket. Okay, and it has a array of values, numbers. Okay, that can be considered as an entries of a matrix. So matrices having just a single row or column is called as a vectors. No? So this kind of matrix here that has only a single rows and columns is called as a vector. Specifically, take note of that. No. So General concept and notation. So we have here a matrix read by m by n matrix. We mean here that the matrix with m rows and n columns, rows always come first, no? So we have here m by n matrix is a uh, a matrix that contains an m rows and n columns. Okay, so that's sorry for this, no. It has a missing information, but anyway, you can just actually have this as your no? So anyway, discuss ko naman. So for example, here is the uh, this matrix, no? So we have here a single, we have here an entities of A11, A22, and A13, A21, A22, and A2n up to A2n, and then AM1 up to AMN. So in here, this notation here uh, means that this matrix have its m columns, no? I mean m rows and n columns. Okay, so if m is equals to n, we call A, or we call matrix A is an square matrix, no? So ibig sabihin, if the number of column and the number of rows are equal, we can call this one as a square matrix. Okay, then its diagonal containing the entries, okay, A11, A22, diagonal, what do you mean by diagonal? This one, no? Itong diagonal na to is called a sa main diagonal of A. So a matrix of any size m by n is called a rectangular matrix. So this includes a square matrices as a special case, no? So all of these matrix here is called as a rectangular matrix, no? So no. Here we are, dito tayo sa vector. A vector is a matrix with only one row or column in its entries are called a component of the vector. We shall denote a vectors by lowercase or bold-faced letter A and B. No? So take note of that. If you will see this kind of notation, assume that this is a notation for a vector that is represented by a matrix. So for example is this one, no? So we have here vector A that is represented by this row matrix is equal to A1, A2, and AN up to AN. So for instance, if you have a 1, 2, 3, 4, 5, 5 entries of row matrix, so we call this one as a row, we call this one as a vector, no? So, and a column vector is in form of this one, no? So, for example, it's this one here, okay? So, basta if you will encounter a matrix that has only a single rows and single column, this is an example of a column, I mean, an example of a vector, okay? So addition and scalar multiplication, matrices and vectors. We have here, if you have a matrix, no, A and B, you can that have the same the same before we define an addition and scalar multiplication of matrix and vector, let us first define these ones. We have here the equality of matrices. If you have a two matrix of A and B that has an index of AJK and BJK that are equal, written as A and B, if this is equal, written A is equals to B if and only if they have the same size and corresponding entries are equal. No, that is A11 is equals to B11. No, so and A12 is equals to B12 and so on and so forth. So those matrices that are equal are called that are not equal are called different. No, the matrices of different size are always different. Okay, so this is self-explanatory. No, you can just read this one. Okay, so example number one. So we have here matrix A and matrix B. Then you are um, if matrix A and matrix B are equal, no? If matrix A and matrix B are equal, then we can say that A11 is equals to 4. This one here is equals to 4. A12 is equals to 0. Then A21 is equals to 3. And A22 is equals to negative 1. Okay? So, this means that matrix A and matrix B are equal. Okay? So, we have here an exercise. No? So, please answer this one here. Now, I have just, this is a um, already solved problem, but I have here a um, missing part, no? So you will just have to identify that one and write it to the separate paper and then submit it to me. Okay? So we have here an additional addition of matrices, no? We have here the sum of two matrices A and B of the same size is written as A plus B and has the entries of AJK plus BJK obtained by adding the corresponding entries of A and B. Matrices of different sizes cannot be added, no? So if you are asked to find the addition of matrix A and B, you could add that one if and only if, okay? If and only if the entries of the two matrices are the same, no? The number of the matrices, ibig sabihin, they have the same column and they have the same rows, no? So if it is not satisfied, so you cannot add the two matrices. Take note of that, no? So for example is this one. If we have a matrix of negative 4, 6, 3, 0, 1, 2, and matrix B is 5, negative 1, 0, 3, 1, 0, then if you ask to find the value of A plus B, or the addition of two matrices, you just have to add the corresponding entries. No? So for negative 4 plus 5, 6 plus negative 1, and 3 plus 0, 0 plus 3, 1 plus 1, 2 and plus 2 and 0. Okay, so you just have to add that one, and then you can have the addition of two matrices. Okay, so exercise number 2. So once again, this is the same as what I have kanina doon. You answer this one and then submit it to me. Okay? Now, dito tayo sa scalar multiplication by a number. So the product of any m by n matrix, okay? And the scalar c. So what do you mean by scalar? Scalar are those quantities that are in magnitude only but not considering its direction. Take note of that. So it's written as CA and is the M by N matrix. Okay. So if you would, it is written and the product is written by C and A, and then it is also a M by N matrix. So ibig sabihin nito, if you will multiply a scalar quantity into a matrix, the the size of that matrix would not affect, no, it will not affect. Okay, so the thing that will only happen is that the entries will change, but the number of entries or the size of that entries will not be affected. Okay, so obtained by multiplying each entry of A by C. So for example is this one, no, if we have a matrix A, then if we multiply that matrix A by negative number, which can be considered as a scalar quantity, so the only thing that would happen is the entries here will change, no, but the size of the entries will not be affected. So the 27 will become negative 27. The 1.8 is would be negative 1.8 would become positive 1.8, and so on and so forth, no. Same for this matrix A. If we multiply that one by 10 over 9, um, um, the uh, entries will just change, but the number of entries will not be affected. Okay, same for this case where we multiply matrix A by 0. Okay, so we have also here an exercise, so you could answer that one also. So we have here rules for matrix addition and scalar multiplication. So from the formula or from the familiar laws of addition of number, we obtain a similar laws for the addition of matrices of the same size m by n, namely. Okay, so we have here a rules. So we have here a plus b. uh, A plus B is equals to B plus A. It means that commutative siya, no? Whether you add the A plus B and or you first write B then A, it is always equal, no? We have here A plus B plus C is equals to A plus B plus C. So this is called as a associative, no? Associative na properties. Okay? This one here is A plus 0 is equals to A. This 0 A here is called as a um, identity matrix, no? If I'm not mistaken. Then A plus negative of that A is equals to 0. So that is the basic properties of matrix, no? Here 0 denotes the zero matrix, no? Of size m by n, of course, no? Syempre. That is the m by n matrix with all entries 0. Okay, so if m is equals to 1 or n is equals to 1, this is a vector called a zero vector. Take note of that. So now similarly for the scalar na rules, I mean for the multiplications na rule, if we have a scalar, uh, then the multiplication of that scalar with the vectors is given by this rule. No? So we have here, kung meron tayong dalawang matrix A, A plus B, then that is multiplied by the scalar C. You will just have to distribute that scalar C to that A and B. Okay? Say then if you have here an addition of a scalar quantity, then you have here a vector na A, then you just have also to distribute that one. Okay? Then if you have a two scalar quantities here and then multiplied by the vector, it is associative, so that you can first multiply K and A or you can first multiply C and K. Okay? So yun. So, dito tayo sa matrix multiplication. So, matrix multiplication, which is a multiplication by matrix by matrix, no? So, the product C is equals to A plus B in this order of M by N matrix, matrix A is equals to AJK times an R cross P matrix, which is B is equals to BJK, is defined if and only if R is equals to N. Okay? Is then the M cross P or by P matrix is suggested by this matrix C, which has an entries of say GK. Okay? Now, what do you mean by this definition? If you have two matrix, no? If you have two matrix, if you have two matrix to be multiplied, you first check the number of rows of the first um, matrix and the columns of the second matrix, right? So if it is equal, wait, let me check it first, no? R and N, R and N, R and N, M and N, rows. Okay, yes. So, you will first to check the number of rows of the first matrix and the number of the column of the second matrix. So if it is equal, you can multiply that one. So if it is not equal, it is not allowed, no? So anyway, meron naman tayong examples dito, so don't worry, no? So we have here the diagram of sizes that shows when a matrix multiplication is possible as follows. Ito yun siya, no? Um, if you have a matrix A that has a number that has an increase of m by n and matrix B that has an increase of n by p, the result is m by p. Okay? So dapat yung number of rows mo and the number of columns o the number of rows ng A mo and the number of columns ng B mo should be the same for you to be able to multiply the two matrix. And the resulting matrix is m has an increase of m by p. Okay? So just read this one actually. Okay? So for example is this one. No? If you have here a matrix of this one and this one, then you multiply that one. So, bibilangin mo muna yung number of rows and number of columns. So, the first one is the number of columns of this matrix A, no? So, you have the number of matrix of this column A. The number of column of this first matrix is 1, 2, 3. Okay? So, 3 columns. Then, the number of rows of this second vector is 1, 2, 3. So, ibig sabihin, the same sila. So, you can multiply this one. And the resulting matrix is 4, yung size dito. So, size of the rows here. So, 1, 2, 3, 4. So, 1, 2, 3, 4. And then, the numbers of column here. 1 and 2. So, 1 and 2. So, ibig sabihin, ito yung resulting natin na um, matrix. Okay? So, for example, is this one. No? We have here um, A matrix multiplied by B matrix is equals to this one. How? You just have to, once again, check the number of rows and the number of columns and the number of rows of the vectors respectively. So we have here 1, 2, 3. Then dito naman is 1, 2, 3. So it means that they are equal. So we can multiply this one. Okay. So what do you do? So we have 3, 5, and negative. I mean, 3, 5, and negative 1 should be multiplied by 2, 5, and 9 first. So the answer is dito mo siya ilalagay. Then 4, 0, and 2 multiplied by 2, 5, 9. The answer is dito mo ilalagay. Then negative 6, negative 3, and 2 multiplied mo siya dito sa 2, and 5, and 9. Then i-add mo yun siya. The answer is dito mo ilalagay. Okay? And so forth. Dito naman, 3, 5, and negative 1. Dito mo i-multiply sa negative 2, 0, and negative 4. The answer is dito mo ilalagay, no? So, and then so on and so forth. Hanggang sa mabuo mo itong resulting na matrix na to. Okay? So, example number 5. We have a multiplication of matrix and a vector. So, we have here, kung i-check na naman natin yung kuan natin, uh, yung condition natin, bago tayo mag-multiply, so we have here 1 and 2 and 1 and 2. So, the same, so we can multiply this one. So, same pa rin, what you will do is multiply first 4 and 2 and 3 and 5. Okay, then add the result. So, the answer is placed here, no? Sa first na row mo. Then, 1 and 8, then multiply mo siya sa 3 and 5. Then, i-add mo yung result. So, dito mo na naman ilalagay. Okay? So, yun. So, the resulting vector is a row vector, okay, which has the same rows of the first, which has the same number of rows of the first matrix and the same number of columns of the second matrix. So 1 and 2, tapos 1 yung kanyang column. So same pa rin, no? We have here. So ganun pa rin, so and so forth, no? So you just have to check first. Once again, you will just have to, before you multiply two matrix, you will just have first to check if the number of columns of the first matrix is equal to the number of rows of the second matrix. Okay? So yan, before you can multiply. So exercise number 4, so please answer this one. Now, so this motivation of multiplication by linear transformation is an additional derivation, no, or additional quantities to be checked when in regards to a having a multiplication of matrix. So please read this one, no. This is just a simple notation, but anyway, this is very important. Okay, so dito tayo sa transposition. Transposition is very important in dealing with matrix. Okay, so we have here a transposition of matrices and vectors. So if you have a vector A that has an intrace of 5, negative 8, 1, 4, 0, and 0, then if you are asked to find the transpose of that matrix A, so what you do is you just change the number of rows, or you just change the position of rows of the intrace to that column of that intrace. For example, is itong 5, negative 8, and 1. Since this is in rows, para matranspose mo yan siya, ilalagay mo siya sa column. So, ibig sabihin, yung 5, negative 8, and 1 mo, dito mo siya ilalagay. 5, negative 8, and 1. Then, yung 4, 0, 0 mo, dito mo siya ilalagay. 4, 0, and 0. Okay? So, then, so and so forth. Same for this one, actually. No? Okay? So, once again, the same din dito. So, you just have to read that one. Okay, so we have here a special matrices. Special matrices. The first one here is the symmetric and the skew matrix. The skew symmetric matrices. So we have here a symmetric matrices are square matrices whose transpose equals the matrix itself. So ibig sabihin, it does not affect. Skew symmetric matrices naman are square matrices whose transpose equals minus the equals the negative of the M matrix. Okay? So for the symmetric, we have if you transpose that one, it will not affected. No, ganun pa rin yung result natin. Okay? Pero for the skew symmetric matrices, if you transpose the matrix, the result is the negative of the original. Okay? So, yun. So, we have here an example. So, please read that one. Dito tayo sa triangular matrices. Upper triangular matrices are square matrices uh, that can have a non-zero entries only on and above the main diagonal, whereas any entries below the diagonal must be zero. Lower triangular matrices naman can have a non-zero entries only on the below of the main diagonal, then any entries on the main diagonal of the triangular matrix may be zero or not. Okay, so ito yan siya. No? For example, is this one. So ito yung matrix mo, ito yung main diagonal mo, tapos sa baba kay lahat zero, so ibig sabihin we call this one as a upper triangular, no? Upper triangular. Then this one naman, if you will see the diagonal na uh, entries, then sa taas kay lahat zero, so we call this one as a uh, lower triangular. Okay? So we have here a diagonal matrices. These are the square matrices that can have a non-zero entries only on the main diagonal. Okay, so any entries above or below the main diagonal must be zero of all the diagonal entries of a diagonal diagonal matrix S are equal, say C. We call S as a scalar matrix because multiplication of any square matrix A of the same size by S has the same effect as the multiplication by scalar. Okay, so we have here this one, no? So we just call this S here as a scalar matrix. No, kasi nga, although it is matrix, but when you multiply that one by another A, the result will not be affected. Okay, as you have multiplied that one by the scalar na C. Okay, so okay, so we have here an example. A problem set, no? Problem set. So please answer this carefully and submit it to me together with the um, exercises that I have shown here, no? Sa taas. Okay, so paki-answer lang yun sila. So I think that's all for today. If you have any question regarding on this topic, please ask it to me right away, no? So once again, good day and please be safe. Okay, so assalamualaikum warahmatullahi wabarakatuh.